Welcome back, Hononegah, Honors Algebra 2, Section 3-6, Quadratic Inequalities. We're going to talk about graphing quadratic inequalities, and what we have to worry about is dashed, solid, and shading. So if we see a less than, a less than, then you're talking about shading below the graph. And if it's just a less than, this would be a dashed line or a dashed curve in this case, or a dashed parabola. And this would be a solid parabola. So if you have a greater than symbol, so y is greater than, this would be shaded above. So you're going to shade above. And then a greater than symbol without the equal to line would be dashed. And then an equal to line would then be a solid parabola. So the graph of any such inequality consists of all the solutions x and y of the inequality. So here we go. This goes over step by step. So graph the parabola as if it were an equal sign. Then decide whether or not to be dashed or solid. Then you can either test a point or, as I just said, above and below, and then shade the region. So here we go. Let's graph this as if it were an equal sign. So negative b, so negative b over 2a. This would give you the axis of symmetry. So the axis of symmetry is -1. Plug -1 back into the equation. You would get +6. So -1, +6 is the vertex. Now, using my shortcut method, if I go left and right 1, I go, in this case, down. So it's always 1a. If I go left and right 2, I go down 4a. The reason it's down and not up is because the a value is negative. I look at the inequality symbol and it's dashed based on the fact that there's no equal to line underneath the inequality. Now it's a matter of shading. You can either test a point or believe me when I say greater than, y being greater than, would be shaded above the graph, meaning every point that I put in this area, such as 3, 3, if I plug 3 in for x and 3 in for y, it would work in the inequality. If I picked another point, such as -5, +2. If I plug -5, +2 in for -5 in for x and 2 in for y, it would work in the inequality. So again, every point that's in the shaded region works. Every point that's inside or not in the shaded region would not work in the inequality. This one is in intercept form. So I know that x equals 4 and x equals 2. So the points 4, 0 and the points 2, 0 are the intercepts to the graph. The halfway point between would be the axis of symmetry, so 3. When you plug 3 in, you get 3, -2. So now, this is also dashed because there's no equal to underneath. And shading, again, we have a greater than symbol. Above the parabola would be inside of the parabola, meaning every point inside. So if I pick the point that was outside, like 0 for x and 0 for y, it does not work, which is why that area is not shaded. Systems of inequalities. All right, so now you're going to do two inequalities graphs on the same picture. So I'm going to do the first one here. The vertex is at 0, -4. Using our shortcut method, over 1, 1a, over 2, 4a. It is dashed because there's no equal to line, and it would be shaded above. Now, I'm not going to shade it yet, but it would be shaded above in the top parabola. The next one, -b over 2a. This would give me my axis of symmetry, so +2. Plugging +2 in, I get to 8. I'm going to do this in a different color. 2, 8 is the vertex. -1 is the a value, so I go over 1, down 1, over 2, down 4, over 3, down 9. So if you wanted to go a little further on this one, it would be solid. It's our first solid parabola because there's an equal to line underneath the inequality. It's a solid parabola, and this one would be shaded below. So the area that is shaded by both graphs, above the dashed one and below the solid one, would be in the middle there, meaning any point that's in that shaded region, such as 0, 0, would work in both inequalities. Your homework assignment will be a worksheet. If you have any questions, please make sure you talk to your teacher, and good luck.